Well, good afternoon, everyone. Sorry for the delay. We needed to get the room ready to go. That's what happens when a room is being used until a certain time down here for conference room A and C. Thank you for joining us today. We're going to be talking about pedestrian and bicycle countermeasures. The title on the screen and what's showing on the webinar here is actually the accurate title. It's pedestrian and bicycle crash types and countermeasures. On the announcement it said ped and bike countermeasures, which makes it seem like they're the enemy, and that's absolutely not the case. We don't want bikes and peds to be enemies. I will be introducing Melissa Barnes really quick, but just got a couple of bicycle and pedestrian related bits of humor that I thought that you would appreciate today. Did you realize that the only difference between a poorly dressed man on a bicycle and a well-dressed man on a tricycle is a tire? Yeah, that's very true. I see a couple of chuckles back there. I've told that joke a couple of times over the past week, and I wanted to make sure that no one stole my thunder with that, so thank you for not doing so. What does a bicycle call its dad? A popsicle. That's one for the kids. I think that the kids would appreciate that more than the grown-ups here. The other one that it's not bicycle related, but I just kind of thought it was funny, is that, I'm just throwing it out there, why not? I just realized not too long ago that Santa must own some riverfront property in Brazil, because we got so many packages from Amazon over Christmas last year that it just seemed to be the case. Anyway, we'll leave it at that. The presentation today is going to provide an overview of common pedestrian and bicycle crash types, as well as countermeasures to prevent them. They could be particularly frustrating because of the random nature and the vulnerability of cyclists and pedestrians. Simple and complex pedestrian crash countermeasures will be presented along with pros and cons and situations for each use. And we are very lucky today to have Melissa Barnes presenting for us. She has 10 years of experience as an engineer and is a statewide pedestrian and bicycle safety engineer, where she works on policies, guidelines, and specific issues relating to a variety of aspects of ped and bike safety and design. She began at MnDOT in 2012. Prior to that, she worked as a professional engineer and consultant in traffic engineering and has a personal passion for bicycle and pedestrian issues. So please help me welcome Melissa Barnes.
Well, thanks, Ken. I don't have any jokes, so you'll have to. You guys are going to have to suffer through data. And Ken already introduced me, so that steals my thunder for the first slide too. So I mean, really, we're striking out here so far. Like Ken said, what we're going to cover today is really common crash types. Who is the most at risk to be in an accident as a bicycle or pedestrian? And common types of crashes, what causes bike and pedestrian crashes the most often. Also, different design features that affect the safety of bikes and peds, and then countermeasure options. And I'll give a little bit of background on any research that's been done, or and whether or not it's MUTCD compliant or experimental. So, just some data. Last year, there were 868 pedestrian injuries and fatalities, and 35 of those were pedestrians who were killed. And then there were 822 cyclist injuries or fatalities and 6 cyclists killed. We often talk about how low the numbers are for pedestrian and bicycle fatalities, but I just wanted to point out how high the numbers are for crashes. So or injuries actually. And a lot of these aren't necessarily serious injuries, but my argument in this is that any time that a cyclist or pedestrian is getting tapped or injured or hurt, that's a problem. It doesn't take that much more speed or that much of a twist in fate, and it turns into a fatality. So these are things that we do need to pay attention to. This data is actually a little old, so it's not going to match the last slide that you saw. But in Minnesota, the concentration really is on males under the age of 25. So the stats you see here are 2012 for bikes and 2011 for pedestrians. The national statistics also show that children, the elderly, racial and ethnic minorities, and economically disadvantaged areas are places that we really need to focus our efforts on too. So common types of pedestrian crashes. Dart out and dash are almost the same thing. Dart out is more often like from between two cars, and dash is just somebody trying to run across the roadway really quickly. Mid-block crossings are areas that we really need to be concerned about. Just walking along the roadway kind of leads to not having a sidewalk. Turning vehicles, left and right turns are both issues. And then although nighttime crashes aren't more likely to happen, they are more severe in nature usually. So common bicyclist crashes at stop signs, actually the problem is both cars and bikes disobeying stop signs. And then alleys and driveways, if you've ever either ridden a bike past a driveway or had a car coming out of a driveway, it's often an expectation problem. You know, cyclists come up pretty fast on the sidewalks or trails, so just watching for those. And then left turns of both cyclists and motorists, and then right hooks, which is what's illustrated here in the picture. The common problem here is where really the motorist doesn't take the right turn correctly. A right turn through a bicycle lane should be taken as close to the curb as practicable and actually within the bicycle lane. And these are some general road rage features. A lot of these are more applicable for pedestrians, but lack of sidewalks, traffic volumes, high speed, wide roads, lack of medians, lighting, intersection geometrics, especially for MnDOT, we have a lot of wide, fast roads, so these are definitely barriers for pedestrian and cyclists that we need to look at. And no presentation on pedestrian injuries and fatalities would be complete without this graphic, so I felt like I had to include it. Speed is deadly. The higher speed, the more likely pedestrians and cyclists are to be fatally injured. So the lower we can keep our speeds, the better. Now, I'm going to have a few slides of these countermeasure options, and there's going to be a ton of them. We're not going to go through all of them. I've highlighted a couple that we will go through in more detail, but I just kind of wanted to point out that there are a lot of countermeasures. There are a lot of options, a lot of different options for a lot of different crash types. So if you're having a specific issue, there's a lot of different things to look at out there to fix it. So things along the road for both bikes and peds, especially sidewalks, bike lanes, things of that nature. Different types of countermeasures at intersections. If you remember the crash types that were the most common, a lot of them were intersections, turning vehicles, turning bikes, stop signs, things of that nature. So we'll go over a couple of those. And then the roadway design in general, and as well as intersection design, so you can design from the ground up if you're starting a new project. Also, traffic calming devices. You ignore the question marks after gateways there. I actually wasn't sure what that was, but if anybody wants to know, it's when you enter a town, it kind of identifies the entrance to a town. So it's signing and kind of saying, hey, welcome to Lincoln or wherever you are. And then I don't think we're going to go through any of those, but they are effective tools, especially to reduce speeds. And then some traffic management measures. These assist both cyclists, pedestrians, and motor vehicles. So if you have access management issues, you can also think about doing things that maybe let bikes through or let pedestrians through, but keep cars from going that direction. Like I said, there's a lot. So signs and signals, different things that you can do all the way from installing a full traffic signal to modifying a traffic signal, putting in different types of signs. We'll go through Couple of the more popular ones right now, the RFB and the pedestrian hybrid beacon. And then others, education and enforcement are really important for to couple with engineering. So we had to mention that. And then there are other just kind of random things: pedestrian streets and malls, traffic control during work zones, things like that. And then this is actually a screenshot from FHWA. It's from pedbikesafe.org. They actually identify the crash type, and then there are countermeasures. It's a matrix paired up with each crash type that you can look at. So this is a really helpful, this is just pedestrian type crashes. This is a really helpful website if you're having a specific problem with a specific type of crash to be able to use. And then there's also one for bikes. So I know this is probably a little hard to see small, but I did want to point out that it's out there. It's useful, and there are lots of countermeasures to different types of crashes. So now we'll get a little bit more into the specifics of some design. I don't know. I like this picture. I think it shows well how bike lanes can really be properly and improperly designed. Drainage is really important in a bike lane. Actually, maintenance just in general is really important in a bike lane. Keeping it clear from debris, making sure that the pavement isn't too potholed, or else bikes can't use that bike lane. And bike lanes themselves are a really positive thing. They separate motorists from bikes, and a lot of times speed differentials is what causes crashes. So you get rid of that speed differential between bikes and motorists. They also provide a buffer between motorists and pedestrians, and then they keep bikes off the sidewalks. So you separate cyclists and pedestrians as well. And these are shared lane markings. They are in the MnTCD. Research indicates that they've really increased the operating space for cyclists. There's cars given more room, cars back off. They don't tailgate them quite as much, and over 90% of the bikes on streets with sharrows ride on the sharrows, which really increases the predictability of cyclist movement, which is huge in preventing crashes. It also reduces sidewalk riding and reduces riding in the parking lane, which is a dangerous way to ride if you're veering in and out of parked cars. You're not predictable, you're not being visible, so these can really help. It also reduces dooring. Dooring is when a car that's parallel parked along the side of the street opens up its door rather unexpectedly and a bike runs straight into the door. So that's something that most cyclists try to avoid, but sometimes happens. So green paint, this is a picture within the city of Minneapolis, right by the U of M. They're actually installing this green paint in the intersection. A lot of times it can be installed right approaching an intersection, really where there's going to be a lot of cross traffic, motorists veering over the bike lane. So the research showed that the yielding of cars in one study went from 87 to 96%. And one of the interesting things that they found was that more motorists actually signaled their intentions to turn, which I thought was kind of a strange output of a green bike lane. And then more cyclists actually scanned for vehicles after the installation of the green bike lanes. Green paint for bike lanes is under interim approval for the MnTCD. And here's kind of an extension of a green bike lane. This is called a bike box. Again, intersections can be a troublesome area for bicycle crashes. Bike boxes are most appropriate for places with pretty high cyclist volumes. It really improves visibility for cyclists and decreases delay. What the cyclist does is they pull forward into that green space when the cars are stopped behind at a signal. It helps the cyclist position themselves for a left turn, and it also reduces those right hook crashes that we talked about earlier. These are still experimental, but they are out there. This is called a buffered bike lane. These do decrease all types of crashes. They're allowed in the MUTCD. They also increase ridership and comfort, which is one of MnDOT's goals, is to increase bicycle ridership. They also decrease sidewalk riding, keeping bikes off the sidewalk. A lot of people are much more comfortable in these than just a regular bike lane. This is called a cycle track. So the difference between the last slide and this slide, the cycle track actually has a physical barrier separating vehicles and cyclists. So that physical barrier can either be parked cars, it can be bollards, it can be a median, but some sort of physical separation. Cycle tracks or protected bike lanes, they kind of have a lot of names, and I don't think anybody's really settled on one yet. The MUTCD doesn't actually control them, doesn't actually weigh in on them, so, but they are allowed. They reduce crashes of all types, increase ridership, and reduce the sidewalk riding, just like buffered bike lanes. In New York City, they found that any street that they put a cycle track on, it reduced crashes of all types by an average of 40%. And some roads they found up to an 80% reduction in all types of crashes. So they have a bit of a traffic calming effect. They separate the users. It can be a very effective solution for places with a lot of cyclists. One thing I do want to point out, it's challenging to implement these at intersections. It's hard to get the turns right. It's hard to get everybody visible. It's pretty important to design these pretty carefully at intersections. And then there's the one we were just looking at was a one-way cycle track. This is a two-way cycle track. So it works with two-way bicycle traffic on one side of the street. These can be even more challenging to implement at intersections, but they work best on one-way streets, really. It avoids a lot of the conflicts at the intersection. This one is called a Contraflow bike lane. This is allowed by the MUTCD and decreases one-way riding. There's a lot of situations where bikes want to get through in the least possible distance. So providing that cyclist the ability to go the other way really assists them and keeps them off the sidewalk. This is a picture of, actually it looks like a nice day, looks like a fun place to ride, but that diagonal parking can be a huge detriment to cyclists and vehicles. Diagonal parking causes a lot of accidents itself. So there's something called back-in diagonal parking, which is actually, I'm sure a lot of you are thinking, who's going to do that? I don't think I could do that. Really, it's no different than parallel parking, and it's the exact same move you make when you're exiting your diagonal parking spot. So if you can't get into a diagonal parking spot and get out, then you can't back in diagonal park. So it really does benefit bikes. If you can see that that motorist is looking directly at the bike, it's also looking directly at other cars. It benefits kids and people who are unloading. When you think about which way your car doors open and your kids head to the back because that's the way the car doors are leading them. Well, if you've backed in, your kids or yourself will be aimed towards the sidewalk. And then they've done a couple of studies on these, and these have showed that in one place it showed that they were having 3 to 4 crashes per month before the installation of back-in diagonal parking, and afterwards for 4 years they had absolutely 0 crashes. So they can really help with visibility issues. Road diets. They provide a lot of space for cyclists. They provide ability to add a bike lane. They also reduce the crossing distance for pedestrians. So there's less lanes for pedestrians to cross, which is always a good thing. It adds room for median islands. It reduces multiple threat crashes, which I'll show you a little bit more of on the next slide if you don't know what that is. And then it also reduces rear end crashes, side swipe crashes, and improves speed compliance. These are appropriate for traffic volumes between usually under 15,000 but up to 20,000 ADT. Advanced stop lines. These I am a huge proponent of. They're a very simple treatment. They are very cost effective, but it hugely reduces pedestrian and vehicle conflicts with the multiple threat crash. So a multiple threat crash is when you have a multi-lane road at a crosswalk. One vehicle stops for the pedestrian, and then their sight is the second vehicle who's coming up behind them. Their sight is occluded by the first vehicle. They can't see the pedestrian. They're not sure why that other car is even stopping, and they continue on and hit the pedestrian. This treatment reduces pedestrian and vehicle conflicts up to 90%. Because our laws are a stop for pedestrian state, we have to put in a stop bar. That creates some design issues when you do it at a four-way intersection. You don't necessarily want to do this at a two-way stop, because you end up with something that looks like a four-way stop to a motorist. They may not see the signs, but they see stop bars on all four legs, and you don't want to necessarily convey that. So this is a really good option at a mid-block crossing, and these are within the MUTCD. Another kind of innovative treatment at signals is a leading pedestrian interval. It's a walk signal given basically prior to the green, so there's a little bit of an additional all red for the signal. It minimizes conflicts and allows pedestrians to enter the intersection before the vehicles. You can, obviously, if you think about it, prohibiting a right turn on red would be great in this situation, but it doesn't have to be done in order to make this effective. There's still a crash modification factor of 0.95 for this. And then I just wanted to show you a little bit of data that goes along with this. So this shows a before and after of conflicts per 100 pedestrians. So this is before they install, the first part of the graph before the dashed line is before they installed any leading pedestrian interval. The second part is after they installed it. You see the conflicts basically went down to 0, and that's during the leading pedestrian interval. And then the benefits also carry along to the rest of the pedestrian walk phase. So the rest of the pedestrian walk phase, because the pedestrians had already entered the intersection, there were still less conflicts between vehicles and pedestrians. So these can be really effective even during the rest of the walk phase. Rectangular rapid flashing beacons. These are pretty popular right now. They're most of the time user activated, so they need a push button to be effective, although they can be passively activated as well. So why are they so effective? Personally, I think because they're bright and they kind of look like a ambulance or a fire truck. So it really catches your eye. You look at them from the side of the road and you almost can't miss them, even in bright daylight. They're really effective for a non-signalized crossing. They've increased compliance in most studies to around 80%, and they stay there. A lot of what we put in, it increases compliance, and then it kind of starts to wane. But they've been studying these for 2-3 years out, and really they get no reduction in effectiveness as long as people push the button. These are MUTCD approved pretty recently. The one thing you have to know, it doesn't create a legal requirement to stop. It's not a red light. It's still just a flashing beacon.
Okay, thank you.
Another treatment that does create a legal requirement to stop is called the pedestrian hybrid beacon. A lot of people call this the Hawk. It's basically a kind of like a mini signal, but it has a different flashing sequence, which we'll cover in a minute. It can have APS, it can have push buttons, it has the countdown pedestrian signal heads. It really does best at mid-block locations, although you can put them at intersections. It does not have any side street heads. That's why they want them at the mid-block locations. Again, this is pedestrian activated. This is something that can be coordinated in a signal system, so that you can maintain coordination on a busy corridor. So this is just a picture of the one we have up in St. Cloud. And then this goes through a little bit of how a pedestrian hybrid beacon works. Normally a pedestrian hybrid beacon sits dark. until somebody comes up and pushes the button. But for the pedestrians, they always see a don't walk signal. And then once a pedestrian pushes the button, there's a short period of just a yellow flash. Then it goes to steady yellow. And then it goes to steady, both red on top. So it's kind of a three-piece doghouse style beacon. And then it allows the pedestrian to start crossing. Once the initial walk signal is done, it alternates back and forth, and then continue. The don't walk goes through, and then it goes back to dark. During the alternating phase, vehicles just have to come to a stop, and then they can continue on once the pedestrian is crossed. These are about as effective as signals. There's a 95% compliance rate, pretty good reduction in crashes, and they're only useful in certain situations, though. This is another thing I wanted to cover. I think these can really help us for some of the temporary situations where we're maybe short on dollars, but we need to do something. These are flexible bollards. This is a picture in Minneapolis. They can create temporary curb lines. So if we're having problems with maybe a radius that's too large and vehicles are driving too fast, and we're trying to tighten up that radius, but there's really no project coming up, these are very, very easy to install. I have one up in my office. It really just takes a little bit of a cord drill. You can spin it right in. They can be removed just as easily. If anybody wants to see one, I would welcome you to come on up. And also, they're visible. You can get them in different colors. I have a bright green one. It looks like a lightsaber. But maintenance is obviously a concern. It's going to take additional snow maintenance. As you see here, I wanted to show you some pictures with snow. But if you're already clearing the sidewalks, you can make these work. And obviously they can get hit by snow plows, but they're also very easily replaceable, and they're easy to take down. So maybe they're not needed in the winter, but they are needed in the summer. And then, like I said, I have to mention that education and enforcement are really important. So I hope most of you are aware, MnDOT has a campaign called Share the Road. There's a separate campaign for both bicycles and pedestrians. It has a lot of educational material on how to drive safely as a cyclist, how to walk safely as a pedestrian, and how to drive around them as a motorist. And then I wanted to also share with you the Minnesota Department of Health, along with Minnesota Department of Transportation, teamed up and produced something called Walk Bike Fun. It's through our Safe Roads to School. So it teaches teachers how to teach safe walking and biking behaviors. This is for elementary school students. It's a really awesome and exciting program, and it's hitting kids right when they're kind of learning and out doing these things daily. And then enforcement. I don't think any engineering solution to like a really bad crash or pedestrian or cyclist problem is really going to take effect culturally unless you have education, enforcement, and an engineering solution. These things all need to work together, and they need to be sustained, and they need to be taken seriously. So you have to have enforcement on board if you really want to change the culture around cycling and walking. There are campaigns, there are different types of automated enforcement. It's important that the enforcement's advertised so people know that, hey, they don't even have to get a ticket. They just need to know it's going to happen, and they never need to break the law. And then I didn't add a slide about this, but there are so many resources out there that could be a whole nother presentation. I just wanted to point out that if you are looking for resources, Google is your friend. That MnDOT has a bikeway facility design manual. There's the NACTO guide. There's tons and tons of guides, and please get in contact with me if you have any questions or are looking for any information.
Can you say what NACTO stands for?
The National Association of City Transportation Officials, I think. So, if there are any questions? Yes?
What percent of the bike accidents are at night in the dark? And if you could repeat the question.
The question was, what percent of the bike accidents are at night and in the dark? There's a significant percent. I can't remember the number off the top of my head, but I want to say around 30 or 40% that happen in the dusk, but not necessarily in the dark. I don't think that's a huge. Not many people are biking in the dark, so it's not a huge percentage. Yeah.
At the beginning of your presentation, you mentioned the right hook crashes. You mentioned this idea that motorists are supposed to be merging into the bike lane conforming with state law that motorists are supposed to be doing. Some of the countermeasures that you mentioned, things like cycle tracks or bike boxes, seem to be maybe in some cases sending an opposite message. So specifically, there are cycle tracks that put bollards along the way that prohibit motorists from merging into that right turn. It sort of seems to be at conflict with the state law, or at least with what the safety messages we presented in the past. Do you see that conflict, or is that how do we get around that? How do we reconcile this?
No, you're right. I definitely think that
The question.
sorry. The question was one of the way to prevent right hook crashes is to make sure that motorists know that they should be taking their right turn as close to the curb as practicable. Things like bike boxes and cycle tracks seem to say the opposite of that and almost encourage motorists to not do those things. So how do we reconcile those things, and what do we think the problem is? I think some of it's education. I think some of it's just getting used to the people who are getting used to driving around these types of things. You're right. I think it is difficult, but I think education right on that one is the key. I don't see if there's design of cycle tracks and intersections is definitely important, and needs to give the motorists clues on how to navigate that. But mostly it needs to be an education thing.
Looks like there might be someone typing a question onto the instant message box.
Okay.
So I need to wait for that to appear.
Oh, yep.
Minneapolis did a crash analysis of crashes only within the city of Minneapolis a year or two ago. And one thing they looked at was trying to assign blame either to motorists or bicyclists in some portion of crashes. And one of the talking points that came out of that was that in the city of Minneapolis, blame seemed to be split pretty evenly, 50-50. Half the time motorists were involved, half the time bicyclists were involved. I'm curious if we've done any sort of similar analysis.
We have. So the question was, the city of Minneapolis did a study on their accident data and found that they assigned blame for the crashes and found that the crashes were about 50% motorists at fault and 50% cyclists at fault. Here at MnDOT, we have done the same analysis, and we found actually the same thing. It's about 50-50 for both cyclist and pedestrian crashes. And that's where our Share the Road campaign is based on that data. So our main message is that we are all responsible. Bicycle and pedestrian safety is a two-way street. We are all responsible for getting home safely because we are all at fault about half the time. So, yep, that we've looked at the same thing and found the same thing actually, which is interesting. Yeah.
In our local paper, there's something about head crosswalks and the law that head walks in the crosswalk, they have the right of way or whatever. I don't know exactly, but the person in the paper was saying that pedestrian has to see that it's safe to step into the crosswalk first. Do you know?
Yeah, so the law is kind of confusing, unfortunately. There's a responsibility on the part of the pedestrian to not step in front of an oncoming vehicle that can't come to a complete stop. That is part of statute. And I forgot to repeat the question, didn't I? I'm sorry. The question was, does the law require a person to make sure the coast is clear before they step out in the crosswalk. However, you can step into a crosswalk if a reasonable driver could come to a complete stop. That's one of those things. It's kind of back to the shared responsibility. When do you feel safe crossing? Do you wait for a complete gap, or do you wait for somebody? Well, as long as they're looking, I know they'll stop. Personally, I try and make eye contact with the driver, make sure that they see me, and if I know that they could come to a stop in that length of time, then I'll continue out walking. But in some ways, they do kind of leave it up to. But you're right, they do have to stop once you're in the crosswalk, if they can do that safely.
And there are some additional questions online, but in that same vein, since we're on that same topic, what is the crosswalk area legally?
So, do you want me to repeat that?
Yes.
So the question was, what is the crosswalk area legally? In statute, a crosswalk is defined at, a crosswalk is basically any intersection. So it's any intersection or any marked crosswalk in between an intersection that connects two ramps. So that's where a person can legally cross the street. And actually, an interesting part of the law is that you can cross the street really anywhere. You just do not always have the right of way. So if you're crossing between two intersections, you can cross as long as you yield to all the cars along the road first. So if the coast is clear, there is no jaywalking law in the state of Minnesota. There may be in smaller towns or municipalities, but it doesn't exist.
Here are some of the questions that came online. How effective are temporary intersection extensions on bike crashes?
I don't understand the question. Temporary intersections?
And maybe you could just, okay, I'll go on the next question. In Winona, the bike lane is striped with a solid line. Motorists feel they cannot cross that solid white line and thus turn from the through lane, which is correct.
So the question was, in Winona, the bike lanes are striped with a solid white line. Motorists feel that they can't cross the solid white line and still turn from the through lane. You should be crossing that line. Actually, the line should be dashed. You can dash the line prior to an intersection, and I think that gives motorists a much better understanding of when they should be crossing the line. And really, a solid white line is just a recommendation not to cross. It's saying please don't cross. But you can cross the white line in order to make a turn into a driveway, in order to parallel park. But normally, cars should be staying out of the bike lane.
Next question, how roundabouts versus intersections affect bike ped crashes?
So the question was how roundabouts versus traditional intersections affect bike ped crashes. So the data has shown that actually it's shown a reduction in pedestrian crashes at roundabouts, particularly the single lane roundabouts. Speeds are so much slower at roundabouts than traditional intersections normally that they can be a benefit. However, I think the jury's still out on multi-lane roundabouts and pedestrian and bicycle safety.
Another question, generally are bicyclists and pedestrian behaviors important in discussing bicycle and pedestrian safety?
Could you repeat that?
Generally, are bicyclists and pedestrian behaviors important in discussing bicycle and pedestrian safety? So
generally, our bicycle and pedestrian behavior is important in discussing bicycle and pedestrian safety. As we talked about with the Share the Road campaign, yes, bicycle and pedestrian behaviors are important, but also motorist behaviors are important. It's equally important that everybody is following the rules, so predictability is important so that we can eliminate crashes. So it is an important part of the conversation, but I think it's important too to recognize that motorists are also part of the responsibility there. Yeah.
I just had a question about if there was any sort of policy regarding free right turns. I know with bike and ped that's sometimes a touchy issue. Is there an encouraged place where that's maybe don't do it, do it? Any opinions?
So the question was regarding free right turns. sometimes a touchy issue with bike and ped movements, and is there places that it should or shouldn't be done? I've been looking a lot into this myself lately because I have the same question. That what I've seen written about in the literature is that for regular sighted bikes and pedestrians, free right turns can actually be safer than hard right turns, which was kind of the opposite of what I would think. You're dealing with one lane of traffic from one direction. It's apparently a simpler crossing. We've also done research in this state and found absolutely no accidents in the last, I think, 10 years for our free rights in Minnesota. That being said, I know that the ADA community does have concerns with free right turns. They're harder to navigate. They're confusing. You can't tell necessarily where the traffic is coming from. So where are they appropriate? A lot of times I think the traffic volume kind of ends up dictating that. Sometimes we're looking at either a dual right at a signalized intersection versus one single free right, and I usually go for the free right in that situation because I feel like dual rights are less safe.
An additional online question, temporary curb lines, how effective are they, and who and what cities, how did the cities decide on adding them? I think it's related to the bollards and things like that.
Sure. Temporary curb lines, how effective are they, and who and what cities have decided on adding them?
How should they decide on using them?
On how should they decide on using them? Temporary curb lines can be effective. A lot of times it just changes the way that people drive their turns. It can also create a temporary space, basically like a bump out or a pedestrian curb extension. How should cities decide? A lot of times I think it's money. Do we have the money to actually do this project here, and what's the need? Do we need to do something right now, but we can't afford to do anything but these bollards? Then I think that's the right time to start bringing these up.
Any other questions?
Oh, yes. I didn't see you mention in your slideshow of a pedestrian safety measure of the orange flags that pedestrians are carrying across the street. And that has been a recent issue
Yeah.
to a certain local agency.
Yeah.
That hasn't cropped up. Just curious if you have thoughts about that or if you can consider research.
Yeah, actually, I have looked into the question was, sorry, this is hard. The question was, have I looked into their pedestrian orange flags that are considered as a pedestrian crossing countermeasure, and what's the research been on those, and what's the effectiveness of those? The orange crossing flags, you're right. My countermeasure list is actually by no means exhaustive. So there's more than I put up there, and I thought that was a pretty long list of them. But the pedestrian crossing flags, which they're currently, I think, using now on Snelling Avenue, they have actually been shown to be effective. They're an effective crossing measure. They increase the visibility of pedestrians. However, there's a couple things that goes into that. It's just like when you have to press the button to cross the street. Who's gonna pick that up? Is everybody gonna pick that up? Personally, I hate to say this, but I probably would not pick it up, and I would just cross the street. The other thing is, there was just an article today that they get stolen. Apparently somebody yesterday made a prank and stole 50 of the flags and scattered them all over the city of Minneapolis. So it can be an issue with maintenance upkeep and an additional cost. So they are effective. They can be effective, but they need to stay where they are, and they need to be used. So.
Well, thank you.
Thanks.
My thought about the orange flags there is if you put a GPS-enabled die pack on those. So if they go too far away from the intersection, poof, then you know who got the problem. I'd like to thank Melissa for sharing. This was a very worthwhile presentation, I think. And there was a question listed through the instant message, but I'll repeat it, that this presentation, as well as the video of this presentation, will be made available on the Traffic Topics website in the next month or so. We're still working out how to deal with some of the issues about posting it online, but pretty soon we should be posting the one from last month online. But the presentation for sure will be made available online. So if you wanted to get that, you can easily get it from going to our Traffic Topics webpage. And the easiest way to find our Traffic Topics webpage is Google MnDOT Traffic Topics, and then we're the top list on that, so you'll be able to find us that way. So, and a little teaser for our next session. Our next session is going to be Traffic Safety 101, and is going to be presented by our own Derek Luer, who is in the room here, and he's excited and really enthusiastic about really sharing this overall subject. He works in the Traffic Safety Unit of the MnDOT Office of Traffic, Safety and Technology. So we're looking forward to having that. So I think that we'll just sign off now, and I thank everyone for being able to come. You know, speaking of bicycles, my daughter recently told me about the hardest thing about learning how to ride her bike was the pavement. Yeah, it was. So anyway, we'll leave it at that. Thanks, everybody. Yeah. Oh, you're welcome. I just put my glasses down. There it is.
Oh, I think, yeah. So Thursday. Chainsaw Safety 101 again.